We start our in-depth tour of general game playing by looking at single-player games, such as Sudoku, or sliding tile puzzles, Rubik's Cube, and so forth. In the game-playing community, these are often called puzzles rather than games, and the process of solving such puzzles is often called problem-solving rather than game-playing. Puzzles are simpler than multiple-player games because everything's under the control of a single player. The world's static except when the player acts, and changes to the world are determined entirely by the current state and the actions of the player. In this lesson, as in most of the course, we assume that the player has complete information about the puzzle. We assume that it knows the initial state. We assume that it knows its legal actions in every state. It knows the effects of its actions in every state. For every state, it knows its reward, and for every state, it knows whether or not it's terminal. In this lesson, we also assume that games are small. That is, the player has sufficient space and time to search the entire game tree. This guarantees that the player can find optimal actions to perform. Now that said, as we'll see, it's sometimes possible to find optimal actions even without searching the entire game tree. Despite these strong assumptions, just one player, complete information, availability of adequate time to search the game tree, the study of single-player games is a good place to start our look at general game playing. First of all, many real-world problems can be cast to single-player games with these same restrictions, such as finding possible protein foldings as suggested by the illustration here. More importantly, for us, as we'll see, the techniques we examine later can be viewed as more elaborate versions of the basic techniques introduced here.